Hi everyone, I am Joni, Department of Computer Science and Engineering. This semester I will take on interesting subject Embedded System and IoT. Embedded system is self-contained microprocessor based computer system typically implemented as a component of the larger electrical or mechanical system. At the core of the embedded system is an integrated circuit that perform a computational task. Then IoT refer to the vast network of physical objects like vehicles, sensor and machine embedded with software, sensor and connectivity, enabling them to collect, exchange and act on data over the internet without human direct and human input. The next is core objective. The objective focus on understanding the how input and output devices such as sensors, switches, LEDs, displays and motors are connected to and communicate with the processor or microcontroller. Students learn how data is sent to the processor from input devices and how the processor control the output devices. Then explain how IoT has developed over a time. From basic embedded system to smart connected devices, it covers how everyday object become capable of collecting data and communicate over the internet and working intelligently using sensor networks and cloud services. Then objective involve hands-on learning where students design and implement simple embedded or IoT project using affordable development platform like Arduino or Raspberry Pi. Then focus on using IoT knowledge to solve real life problems such as smart home automation, environmental monitoring, healthcare system and smart agriculture. Our first unit is 8-bit embedded processor. It's a small computing system where the processor handling data 8-bit chunks. It integrates a CPU, memory, input and output ports, timer and serial communication on the single chip. That the architecture describes the internal structure of the microcontroller. It includes a components such as CPU, ALU, register, program memory, data memory, and the input and output ports, timer, counters, and interrupt system. Then instruction set is the collection of commands the microcontroller can execute such as data transfer, arithmetic and logical and controls instruction. Programming involves writing the instruction. Then programming parallel ports the microcontroller to communicate with external devices using multiple data lines at the once. Then timer, it is used for generating the delay and counter event or measuring the time interval. Serial ports to enable to communicating with other devices using port protocols like UART. This feature are essential to the tasks such as data transmission. Then interrupt handling allow to microcontroller to respond immediately to the important events such as external signal, timer overflow or serial communication. When the interrupt occur, the normal program execution is paused and special runtime is called interrupt service routine. It's executed. Our next unit is embedded C programming. This topic explains how memory and input and output devices are connected to the processor or microcontroller. It includes addressing scheme, control signal and data transfer method that allow the processor to read from and write to external memory. Then embedded C is used to write programs that directly interact with hardware. This includes configuring registers, controlling input and output ports, handling interrupts, and managing timing. Programming in C makes embedded software portable, readable, and efficient. Then why need for real-time operating system? It's a record when an embedded system must respond to even within strict time limit. It provides predictable timing, efficient task management, and resource control, which are essential for real-time application like automotive system and industrial controller. Then multiple task and processor. This concept deal with executing multiple tasks simultaneously at the same time. Its embedded system tasks are small unit of work and the RTOs manage their execution so all system function operate correctly without conflict. Then context switching is the processes of the saving the stage of currently running task and restoring the stage of another task. This allow the Arduino's switch between task efficiently and gives the impression of parallel execution on a single processor. Then our next unit is IoT and Arduino programming. First I'll tell about IoT. It's a device or smart physical object that can collect, exchange and act on data through the internet. Its example include a smart wear thermometrics is a wearable fitness tracker and a connected home appliance. IoT enable automation and remote monitoring in every life. Then IoT devices usually perform a single or specific set of tasks while computer are general purpose. Then IoT devices have limited processing power, memory and storage. Then IoT configuration have set a three level of sets, say device to device and device to cloud and the device to gateway. Then basic components of the IoT sensor, processor or controller, communication modules and power supply. Then Arduino is an open source microcontroller platform. It is used to build a IoT and embedded project. It is easy to the program, affordable and has a large community for support. Arduino board can read sensor, control actor and communicate with other devices. It have some set of types Arduino into Arduino Mega, Arduino Nano. Our next unit is IoT communication and open platforms. Communication model define a IoT devices exchange the data for three levels. Device to device, its mean device communicate directly without a central server. Then device to cloud, devices send the data to cloud server for processing and storage. Then device to gateway, devices send a data logical gateway which manage network connection and relay data to the cloud. Then APIs means application programming interface. It allows software on IoT devices interact with other application or cloud services. Then IoT communication protocols. It have some list is HTTP and message queuing, terminally transport. Then content application protocol. Then advanced message queuing protocols. Then have the Bluetooth, Wi-Fi and Zigbee and GPS, GSM module enable the IoT devices to communicate over the cellular networks. They can send and receive SMS or connect to the internet using mobile data. These are used to application like remote monitoring, tracking system and automation alert. Our next unit is application development. It have some step. First step is requirement analysis, then hardware design, then software design, then integration and testing, then deployment. The deployment of IoT application is involved the application involvement, connecting devices to sensor and actuators, the programming microcontroller, sending data to the cloud server, processing and analyzing the data, providing user interfaces. Then smart agriculture is a IoT in an agriculture help to farmer monitoring soil moisture, temperature, crop health and irrigation system. Sensors send the data to the central system which can automate watering, fertilization and pest control. This improve the crop yield and this resource efficiency. Then smart cities IoT enable the cities to be more efficient, safe and suitable. Example, intelligent traffic management, smart street lighting, waste management system, then environmental monitoring. It control the air, water and soil pollutions. The next one is course outcome. This outcome focus on understanding the internal structure of embedded processor, including components such as CPU, memory, register, input and output ports, and the buses. Student will learn how the component work together, execute program in embedded system. Then embassies programming skills using embedded C. Students learn how to write, compile and debug programs that interact directly with hardware such as controlling LEDs, reading sensor values or handling interrupts. Then involve applying both hardware and software knowledge to create basic embedded system. Example, include temperature monitoring system, traffic light controller and alarm system using microcontroller. Then understanding and comparing different IoT communication models. Then developing the basic IoT application using popular open platform like Arduino or Raspberry Pi. Students learn to interface sensor, connect devices to the internet and develop real world IoT solutions such as smart home and monitoring systems.